I would like to advise you that I will solve some examples on a board, but I'm going to put my notes in the description, reference for the notes in the description. You can download that one, number one. Number two, you subscribe it, you press the like button and also the button for the bell, so that you can get the new videos related with the linear algebra to you. So we are going to take an example and we try to solve it to find A inverse using elementary matrix method. I'm going to take this example. I take this example. I define my matrix A. So my matrix A must be a square matrix. I have taken the last example 2 by 2. This example I'm going to take here 3 by 3. And this example we are having here the matrix 1, 3, 1, and having 2, 2, 1, and 2, 3, 1. As I told you about the method, we take matrix A, we take identity matrix, and we try to reduce matrix A to matrix I. Then this matrix I will change to inverse. This is the main theme of the method. Now, if we are able to get here identity matrix, then this will be inverse. If we are not able to find it, this is not A inverse. Now we just start it, and we take here A, I. It's my A. My A is my matrix A. That's 1, 3, 1, 2, 2, 1, 2, 3, 1. And we are having here the identity matrix 0, 1, 0, 0, and then 0, 0, 1. We make the row operations. Our row operation will be that we retain 1 here, this leading entry. We want to make this one 0 and this one 0. Will be here minus 2 R1 plus R2 and minus 2 R1 plus R3. So I make this row operations. I can get here the equivalence form. Row 1 remain the same. We are having here 1, 3, 1, and we get here 1, 0, and 0. Now we multiply minus 2 add to this one. Minus 2 plus 2 will be 0. Minus 6 plus 2 will be minus 4. Then we are having minus 2 plus 1 is minus 1. Then multiply minus 2, we get here minus 2, 1, and 0. Then multiply minus 2 add to this one, we get here 0. Multiply minus 2 add to this one, we get here, this will be minus 6, and 3 will be minus 3. Then multiply by minus 2 add to this one, we get here minus 1. Then get here minus 2, 0, and 1. Now we want to reduce it to the identity matrix. This means we have to bring here the values which are, this must will get here 1. So to bring here 1, I multiply here by minus 1. So I get here this is equal to 1, 3, 1, 1, 0, 0. I get here 0, I get here 4, I get here 1. I get here 2, I get here minus 1, get here 0, I get here 0, I get here minus 3, I get here minus 1, I get minus 2, I get here 0, I get 1. To bring here minus 1, I add R2 and R3. This here is, I just multiply minus 2 minus R2. Now I can just write it here. I have 1, 3, 1, I get here 1, 0, 0. So my operation is minus, this is here R3 plus R2. So we add it, we get here 0, we get here 1, we get here 0, we get here 0, we get here minus 1, and we get here 1. Here I have 0, minus 3, minus 1, minus 2, 0, and 1. So next is I want to make this one 0 and this one 0. So I take operation on row 2. That will be minus 3R2 plus R1, and second operation will be 3R2 plus R3. Now let us see what we get here by making this operation. We are having here the operations are on second row. This is 0, 1, 0. And then we are having here 0, minus 1, and 1. We multiply here by minus 3 R2 plus R1. So we get here 1, minus 3 plus 3 is 0. Then this remain 1, 0 plus 1 is 1. 0 plus 1 is 1. And multiply minus 3, this become here 3. Multiply minus 3, this become here minus 3. Now the last one is multiply with 3 R2 plus R3. So multiply by, this is 0. Multiply with 3, add to this one. 3 plus 3 minus 3 will be 0. The 0 is become minus 1. Remain minus 1. 0 plus minus 1. Then it remain minus 2. Multiply with 3, add to this one, get minus 3. Multiply with 3, add to this one will be 4. Now this minus, I want to change it to plus. So multiply the last row by minus 1. And we'll get here this equal to 1, 0, 1, 0, 1, 0, 0, 0, 1. And here we get 1, 3, minus 3, minus 2, minus 3, and 4. They give me, this will be here 0, minus 1, and 1. Multiply minus, get 3, and we get 4. Last row, we multiply minus sign. Now only 1 is left. I want to make this one 0. So multiply minus 1, add to this one. So this will give me here, I have here 1. Multiply 0, add to this one. Multiply 1, minus 1, add to this one. This becomes 0. Multiply minus 1, add to this one. They become minus 1. Multiply minus 1, add to this one, becomes 0. Multiply minus 1, add to this one. This become here 1. So what I did, let get here minus R3 plus R1. So the next is 0, 1, 0, 0, 0, 1. And here get 0, no change. And here 2, 3, and minus 4, no change. So what I get here I, and this is my now A inverse. So I say my A inverse is a matrix minus 1, 0, and 1, 0, minus 1, and 1, 2, 3, and minus 4. So this is my inverse of the matrix. So that's very interesting. Again, I just repeat that we use this method, elementary matrix method, and we wrote here AI, and make the row operations, change its I, A to I, then I will change to A inverse as I got it here. So I say this is my A inverse. Now what's the application of A inverse? So if you remember, last lecture, we discussed the properties. Very important properties was when we multiply A by A inverse, I get the identity matrix. You multiply from the left or I multiply from the right. A inverse A is also equal to I. I is the identity matrix, and you multiply I with any matrix, the matrix is not changed. So these are the two properties which I will use to see the applications of this one for finding the solution of the system of linear equation. That's the main target.